What is up, losers? I got a bowl of whitewashed chili. Shut up, phone. I got a bowl of whitewashed chili, and the monster I drank this morning is still kicking it. So today we are going to do some math. Hooray. Anyways, so for this first one, we're going to be doing sequences, which are all fun and dandy. I love struggling at basic math. Anyways, so this is the sequence right here, obviously. Where else do you see sequence? And the first question is this series arithmetic, geometric, or neither? So the first thing we gotta do is, let's subtract -5. Wait, no. Let's subtract -11 from -5, and the difference would be, +6. Okay, so if you add +6 to -5, equals 1, and we got that, and if you add +6 to 1, it equals 7. So this is arithmetic. Let's write that down, all fine and dandy. Ignore how horrible I am at writing words, apparently. I'm a bit off today, because I just spent 4 hours straight on a single assignment without, doing anything else during that entire time span. So, that was great. Okay. So the next one is write the recursive and explicit formula for the sequence. So let's see. So a recursive formula.
Hold on. I'm going to get a bit distracted. Okay, so the recursive formula for
arithmetic sequences is, a n equals a parentheses n minus 1 parentheses a minus 1 plus the common difference. So let's see. So a n equals a n minus 1 plus, and the common difference is +6. So it would be 6. Hooray! Now let's do the explicit formula if I can remember what that is. Okay, so the explicit formula is an equals, hold on. Okay, an equals a plus n minus 1 times the common difference. So it would be an equals a plus n minus 1 times d. I'm going to check that, actually. Wait. Don't look at any of that. Sorry, I'm having a hard time remembering stuff right now. Okay, so yeah, that was right. Well, mostly. It's that. Hooray. Anyways, so now we have to use the explicit sequence to figure out what the 16th term would be. So it'd be, let's see, so an equals, let's see, so a1, and a1 would be the first term, which would be -11, plus, so n minus 1, that would just be 1 less of this one, which is supposed to be 16. I actually thought about writing it like that, and then I forgot to write it like that. So 16 minus 1 would be 15. So it's 15 times, not D. I am struggling. 6. People are going to see this. My math teacher is going to see this. And he's going to watch me as I go insane over basic math. Anyways, so now let's solve this Yankee Doodle Dandy. So 15 times 6. I gotta get my calculator for that, because I'm not that smart. So 15 times 6, that equals 90. Wow. And then minus 11. Just 90. So it'd basically be 90 minus 11, which would equal, 79. So, A16 equals 79. Great. So smart. I did it all by myself. Watch as that's wrong. Anyways, let's move on to the second equation. Second problem. Okay, so first question. What is the sample space for flipping a coin? So the definition of sample space would be possible outcomes. And if you flip a coin, there's heads and tails, so that's That's the sample space, heads and tails. So smart. Okay. Second question. You have a bag with 4 green cookies, 3 blue cookies, and 2 yellow cookies. So let's write that down real quick, actually, while we're doing this. Oh, hey, green. I'm writing with green. That's funny. So, blah. So G is equal 4. B equals 3. And Y equals 2. So G is green, B is blue, Y is yellow. Probably could have thought that, assumed that, but whatever. You reach and randomly get a cookie. You eat the cookie, then you reach in and grab another cookie. What is the probability of getting a blue cookie and then a green cookie? Show your work and explain. So if we add all of these together, we should get the total amount of cookies. So 3 plus 2 equals 5, and then 5 plus 4, that equals 9. So there's 9 total cookies. If there's 3 blue cookies and there's 9 total cookies, that would mean that there's 3 out of 9 blue cookies in the first one. So let's see, times. And then in the second one, there would be 1 less total cookies. So it would be out of 8. And the second cookie that you pull would be a green one. So it would be 4 out of 8. Which is also, blah, 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 which is also 1/2. Okay, so now we multiply those together. 3 times 1 equals 3. 9 times 2, that equals 18. And then, here's the fun part. Hold on. Wait. Hold on. Get ready for this. You divide both the top and bottom by 3 to get the simplified answer. So if you divide by 3, that'll get you 1/6. And that's the answer for the second question. I totally did not pull up my calculator for that. You're crazy. Okay. You spin a spinner and get a 4. Then you roll a die and get a 3. Are those events independent or dependent? How do you know? Okay. So I'm really glad that I'm recording this and that I don't have to write down the reasoning because I hate those in problems. But anyways, it would be independent. Dependent. Because the spinner would not affect, like, what you get if you roll a die. Okay, like in the previous question, that was a dependent. That was dependent. The second, the probability of getting a green cookie after you pulled out a blue cookie was dependent because you changed the ratio when you pulled out a cookie the first time. But in this one, if you spin a spinner and get a 4, and then you roll a die and get a 3, that won't affect each other. Because no matter what you spin in a spinner, it won't change the things you can get if you roll a die. So it's independent. Okay, that was it. Thank you for listening to me slowly go insane. Bye.